In this lecture, we're going to explore the case where you are declaring the class, but at the same time, you want to use member variables of the same class. Let's look at an example. Here we have a point class. It is an innocent point class. We have a public section inside. We have a private section inside. And down here, you see we have a bunch of problematic member variables. You see, we are setting up member variables of type point in the declaration of the class point. And sometimes you want to do this. And a possible example of this is, for example, if you want to set up the origin point and you want to model something like a line. You will need the origin point or the starting point for the line, and you might model that as a member variable inside the point class here. So this is something possible. But if you try to set up your member variables in any of these ways, if you set up like m_origin_point_1 here, or make it const, or make it a static inline const variable, you're going to get a compiler error that says that the type is incomplete here. And what this really means is that you are trying to set up a variable of the class you haven't finished building yet or setting up yet. So the compiler isn't really going to have enough information to set up these member variables. This is the message here. Okay, so if you try to use any of these syntaxes, this is not going to work and you need to be aware of this. However, there are ways we can make this work. For example, if we make the member variable a pointer like you see here, the compiler is going to take this because a pointer really is not a point type. It is just a pointer to a point, and we have the option to specify this point later when our program is running. So again, this is going to work because p_m_origin_point_4 here is not a point type. It is a pointer to a point type. So this is going to work. If we have a setup like this, we might want to initialize our pointer member variable like we see here, and initialize this with null pointer. And this is going to work if you use null pointer. But if you don't use null pointer and, for example, inside your initializer, you say new point, you try to set up a new point, you're going to get something wrong. Try to think about this. You are trying to build a point. This is a constructor for the point class. And in the same constructor, we are trying to call another constructor. We say new point here, and this is going to call the constructor again. So what this is going to do is really set up a chain of recursive calls to the constructor for point, and it will keep calling itself, for example, billions of times, and at some point you're going to run out of heap memory and your program is going to crash. Please note that C++ is not going to protect you from this, or I should say C++ compilers are not going to protect you from this. A solution to this is to initialize our pointer with null pointer and later set it up if we really need to do this when the object has already been constructed. We're going to see an example of this in a while if this is not making sense yet, so bear with me. This is going to work in a minute. Another way we can set up member variables of point here is to use static member variables like this. The static member variables can either be constant or not const. This is going to work because this is going to delegate the initialization of point at some later point in an implementation file or a CPP file, and the linker is going to look for this later when the program actually gets to run. So the compiler is basically going to say, okay, I see a setup for a member variable for point, but I can leave it for later to really put in a value, and I am going to accept this. The syntax is going to work because the C++ compiler is going to see that it can initializing this properly later when we hit the linker stage and we are building our program. So this syntax is going to work here, but you need to be aware of the syntaxes that are going to give you compiler errors, and you need to be aware of these errors here. Okay, with these member variables in place, we can initialize them in a CPP file. For example, here we are initializing m_origin_point_5, and here we are putting value inside m_origin_point_6, and this is going to work just fine. Now that you know this, I think it is time we headed over to Visual Studio Code and play with this a little more. Okay, here we are in our working folder. The current project is member variables of type self. We are going to reuse a project we have done before, and that's what we see here in line static member variables, and we're going to grab whatever we have inside. We're going to grab the VS Code folder here. We're going to grab the main CPP file and the point class, but we're going to leave out the binary here for Rooster because we're going to be generating our own. We're going to grab those files and put them in the current project, and we are going to open this up a little bit in Visual Studio Code. This is going to open our project, and we will have our main CPP file. We can remove anything we have inside because we're going to be setting up things later. And we're going to open the point class, the header, and the CPP file. Let's do that. Okay, so we have our class here, and we want to set up member variables of the point class that we are declaring here. And we're going to see how this plays out. I am going to go on top here and put all this in its own public section. It's not going to matter if it is public or private, but I want this to be separate from our private member variables here. So we're going to set up a point member variable. It's going to be point, and we're going to call this m.1. And if we try to do this, notice what we have here. Okay, so let's try and build before we put this in to try and prove that the program is just going to work fine. And it is going to be the change that we have here that is going to break our program. You see, the build is good. So let's put our point 1 in here. And the moment we do this, we're going to get a squiggly line from Visual Studio Code. This is going to be a warning. And it is going to say incomplete type is not allowed, because at this point, we are trying to set up a point member variable, but the class is not declared to completion yet. So the compiler won't really know how to set up this. You're going to get an incomplete type compiler error. Okay, so this is what I want you to be aware of. If we ignore the warning from Visual Studio Code and just move on with whatever we want to do, we're going to get a compiler error, and it is going to say the same thing. Field m.1 has incomplete type point, because we haven't finished building the point class yet, and we want to set up its own member variable, so this is not going to work. If we try and make this const, for example, we say const point m.2 here, this is also not going to work. We're going to get the same compiler error. Let's wait for Visual Studio Code to realize the problem. We're going to get a squiggly line, and again, we're going to say field m.2 incomplete type. We should say point 2. Let's build again. We're going to use GCC, and now the problem should be updated. Point 2 has a complete type, and the compiler error is going to say the same thing. m.1 or m.2 has an incomplete type, so we can't do this either. So this is also going to give us the same compiler error. But if we try to set up a static variable and make it in line, we're also going to get the same problem, because that will force the compiler to initialize the variable in place here. And that's not going to work. We're going to get the same compiler error here. Let's give you an example. We're going to say static inline const and say point and say m.3. Let's say 3 here. So if we try to say static inline const point and say m.3 and try to initialize this, for example, because we can do this if the variable is in line, we're going to get the same compiler error because the type is incomplete. We're going to get this because the compiler will try to initialize this guy, but we don't have enough information to build a point object. So we're going to get an incomplete type compiler error. Let's build this so that you can really see this with your own eyes. The build is going to give us an error because we don't have enough information to build a point object like we do here yet. So we're going to get the same compiler error. Okay, so now you know this. But there is a way we can have member variables of the same type even if the type is not complete yet. One way to do this is to use a pointer. So for example, if we say pointer and say pm point and say 4 here, you see that this is not going to give us a compiler error. In fact, it is going to compile. We're going to build with GCC, and we're going to see that the build is good. So this is valid syntax. The reason this is working is because a pointer to a point is really not a point. So the compiler has no problem setting up this guy. because all it really needs to know is that this is a pointer. It is going to have the size of a pointer on my system, and the compiler can leave the details it doesn't have for later when somebody tries to store something in this pointer. So this is going to work. We're not going to get the same compiler error we had here. Let's save the errors for all the other cases here so that it is super clear. Let's do that. But this is going to work. Okay, so if this is taken in, we can grab this and try to initialize this when we build any point object through the constructor. So for example, we can come here and say, we can put this in front. I think we can do that. And we can initialize this with null pointer, for example. And this is going to work through our initializer list. Let's use curly braces because we want to be consistent here. And this is going to work. You see, if we try to build, the build is going to be good. Okay, this is building successfully. But one problem some people might have is if they try, for example, to initialize this using the new operator and try to construct a point in place. I know some people are going to do this. Let's take out null pointer here and say new point. Okay, if we do this, this is going to call our constructor here, and we're going to land in this place here. But try to think about what we are doing here. If we come in main, for example, and say point P1 and we say something like this, this is going to come and call our constructor here, which is not taking any parameter. We're going to delegate to our constructor on top here, and this constructor will try to set up a new point object because that's what we are saying here. But this is also going to call this same constructor again, and we will keep calling this constructor endlessly. And at some point, the compiler is going to see that this function is calling itself repeatedly, and we're going to be allocating memory, for example, for billions of times, and we are going to run out of heap memory for our program, and we are going to get a crash. Let's try and run to really show you this. The compiler is not going to protect us from this, so the build is really good. We can clear, but if we run Rooster, notice what happens here. The program is basically going to keep creating new point objects because the constructor is calling itself billions of times, and at some point we're going to crash the program. The operating system is going to say this program is crazy. It is creating billions and billions of objects of point type, so it is going to die. If we wait, we're going to see that this program is going to die, but I don't want to wait all this time. You have seen the main message here. It is crashing. It is not doing anything. We can hit Control C to stop this. And now you know that this is really bad. You shouldn't do this. If you want to do something like this, it is advised to initialize your pointer to null pointer and then do the work to put in some data later when you want to do this. For example, we can go in our point class here, the declaration for this, and we can set up a function to initialize that pointer member variable. For example, we can say initialize our pointer. Let's say initialize pointer, and we're going to put in the values we can use to initialize that, and we're going to initialize our pointer member variable. For example, we can grab that here. I think it is this little guy here. We can grab it and say we want to initialize this pointer, and we're going to create a point object, and we're going to let this pointer point to this. When you do this, the initialization of this memory location is going to be left for later when a point object has been already created. For example, here, if we have point 1 here, we can come down and say point 1 and say initialize. How did we call the method? We can grab the name here. I don't remember the name. And we can say initialize our guy using 10 and 10, for example. And this is going to work. Let's build. You're going to see that the compiler is going to accept this. And we have a problem here. Which problem do we have? Request for member initialize pointer in P1, which is of non-class type point. For example, if we use the point here, and here we have a problem. What we put here is not really good syntax to create a point object. This is not going to create our point object. This is basically going to be interpreted by the compiler as a function called P1, which is not going to take any parameter, and it's going to return a point object by a value. So sorry for this. This is referred to in C++ as the most vexing parse. And it is basically a situation in which C++ can't really know if we are declaring a point object or declaring a function. And this is a situation in which C++ is going to be confused and think we are creating a declaration for a function when we really want to create a point object. To remove this confusion, for example, we can either remove the parentheses here. This is going to be a point. This is going to call the default constructor that we have declared here. Or we could just pass in parameters. We can, for example, pass in 5 and 5. We can do this. This is going to be a valid point. Now that the valid point is created, we're going to take it and say initialize pointer, and we can pass in whatever we want. Let's pass in 10 and 10. And our pointer member variable is now going to be initialized to a point object that is pointing to a point with these values inside. And if we printful, we're going to get the information for our point in place. For example, if we say this guy and say printful, we're going to see the information, and this is going to work just fine. If we build, this is going to build fine. Let's see this. You're going to see that the build is good. We don't really care to print the information because if we do, this is just going to give us, let's see what we're going to get if we print information. We're just going to print the addresses for the member variables. And this is really not what we are interested in. But the important bit is that we had to initialize our pointer member variable after a point object was already created. Because if we go in the constructor and try to say new point here, we're going to get a problem because we're going to get the constructor to call itself multiple times, and we're not even going to hit the body. We're going to be basically keeping calling the point constructor, and the program is basically going to hang, and eventually it is going to crash when we run out of memory for the point objects here. So we don't want this. We want to initialize this to null pointer here, and then initialize that pointer through some member function if we need to do that. Okay, this covers the point where we want to set up a pointer member variable. We're going to comment this out, and I am going to show you two other scenarios where this is going to work. And this is basically going to work if we use static member variables, but we don't make them inline. We leave the initialization for them in some CPP file. So let's do that. We're going to say static const point, and we're going to say m.4, and we're going to set up another one which is not const. We're going to say static point and say m.5. This is going to work, and we can head over in the CPP file and initialize these guys. We can copy them and put them in the CPP file, and we can come on top here. And we can say const point. We're going to remove the static here. And we're going to say that this is declared in the point class. And we're going to initialize this to a point object. We can do that. We can say point, for example, and put in a value of 4 and 5. Why not? This is going to work. And we can do the same for this little guy here. So let's take out the static. This is going to be our type, and we're going to say that this is a variable from the point class, and we're going to initialize this to some point. Let's say point, for example, and use curly braces and put in 3 and 8. This is going to work. If we try to use these guys, we're going to get what we expect. And we took out this pointer. I think we should bring it back because it's not going to crash our program or give us a compiler error. So we can build again. If we build, you're going to see that this is going to work. You see the build is good. We can use member variables of type self if we are declaring static variables and not making them inline. This is really all I wanted you to see in this lecture. I hope you found it interesting. If you happen to want to set up member variables of the same class you are declaring, you should really be careful. Because if you use the syntax we see here, you're going to get a compiler error. But if you avoid these syntaxes and, for example, use pointers or static member variables that are not inline, this is going to work. Because for pointers, the C++ compiler is going to say, okay, this is a pointer. I can leave it for later to put in the details. And you can initialize the pointer later when you are creating your object here. This is going to work. For static member variables, you're going to leave the proper initialization of the variables in some CPP file, and the compiler is going to take this and it is going to work really well. So for example, we have these guys initialized here. We have m.4. I think we can grab this in the main function and use it. For example, we can say p1 m.4. We can have access to that, and we can say printful. Let's change what printful does. I think this is going to be educational. Let's go in and change that to say, and print the member variables instead of printing the addresses directly. We can do that. So we're going to say my and mx here, and we're going to build again. The build should be good. So we're going to clear and run Rooster, and we're going to print the information in 0.4. And if we go in our CPP file, we're going to see that we initialize that to 4 and 5. And that's what we see here. It is working exactly like we want. We are going to stop here in this lecture. In the next one, we're going to see that we don't have these limitations if the member variable is not of self type and we are using our own class types. So go ahead and finish up here and meet me there.